Hello, I am Daneau from the Renault Group, and I would like to share with you the subject how to structure and capture industrial data with scalability. A short presentation of my personal background. I have 35 years of experience within the Renault Group in various professions such as maintenance, process engineering, industrial IT, and automation. I work in France in the Renault Techno Centre located in Guyancourt near Versailles. Since 1916, I have been working as an expert on automation and robotic technology and architecture. As such, I enlighten the company on the technological choice for the future of our factory. I am also product owner for the industrial data capture project for Renault Group. A quick overview of the Renault Group in the few figures. Renault, it is 5 brands: Renault, Dacia, RSM for Renault Samsung Motor, Alpine, and Lada. And one alliance with Nissan and Mitsubishi. For the Renault Group on the industrial side, there are 38 production seats and 13 logistics seats in 16 countries. Regarding production volume, we produce more than 3.5 million vehicles and about as many engine, gearbox, and chassis. In 2016, Renault launched numerous digital initiatives in a benchmark factory in Spain. From this experience, in 2017, we launched many digital transformation projects. This project revolved around 5 major pillars: real-time data-driven operation, full track and trace, flexible supply chain and plant, process 4.0, and connected workforce. The subject that I will detail in my presentation lays the foundation for several transversal subjects. Regarding the subject of industrial data, over time we have accumulated numerous technical solutions which have partitioned the data by typology. Several examples allow me to illustrate my remark. An example on traceability. In powertrain plant, an Atlas Copco system when we have Atlas tightening controller, and for conditional benzene maintenance and robot, we have a specific system per brand. If we talk about automated installation, we have installation from the 18s to today and significant diversity of automation and protocol components. Each of the technical solutions has its own architecture, and when we try to mesh data, it is very complicated. When we look at industrial installation, we have a lot of data from industrial equipment such as PLC, input-output, Boolean, robot, vision system, variable speed drive. If we look at the functional need, we need answer on product traceability, process traceability, measure, state of stock, photo, and video. For end customer, we see that data is of interest to many businesses in the company: quality, energy consumption, maintenance, automation, and manufacturing. To meet these multiple needs, we have defined a standard for data capture, and we have a strong slogan that is spread through the company with a common target: collect once and use many. For the capture of industrial data, there are 2 essential layers: the industrial layer repository where we have defined the data model and the single publication table. The data acquisition layer where we collect structured data from different industrial equipment. The condition for success for this digital transformation to succeed: the common data dictionary, the unified information structure, the granularity of the data for a maximum of use case, a worldwide standard, a common automation and IT approach. To meet this condition, we have chosen the OPCUA technology with the approach of data model. This element will make it possible to meet the challenge of the factory of the future, where we have unified data capture, interoperability, machine-to-machine communication, edge, cloud, and big data, machine learning, artificial intelligence, and digital twin. Here is a quick overview of the architecture implemented with 3 levels. A first level at machine level, where we have implemented a software we call UDC for Unified Data Collector. This software transforms all proprietary protocol into OPC UI with a structured data model. A second level at the factory level, where we have implemented a software we call DFA for Data Flow Aggregator, where we aggregate factory data to send them to the internal cloud until mid of 2020 and Google Cloud Platform since that date. Some interesting data on the capture of industrial data. 3,300 devices deployed in OPC UI, 300 billion data collected since the start of the project, data from 17 factories representing a flow of 10,000 messages per second. We use OPC UI technology for Industry 4.0. From Industry 4.0, we have more than 1 million measuring points. We collect different forms of data, Boolean, string, analog value, table, file, and image. The organization we have to implement all the fundamentals of the data capture project are a team dedicated to the data model made up of multidisciplinary group from OT, ISIT, and process engineering, which has already made 40 data models for the powertrain plant, 10 data models for the vehicle plant, with a target on the creation of 200 data models. A team dedicated to software development with 4 fundamental building bricks: Magic Draw plus add-on for data model, UDC for industrial equipment, DFA for aggregation, and Google Cloud Platform for the publication table. The target rate is to be plug and work. A deployment teams made up of factory and corporate automation engineers to implement in the UDC in industrial facility. We first deployed 100 piece equipment in 2018, 900 in 2019, and 2,000 in 2020. The current target is to deploy on a large scale. An OT and ISIT monitoring team to monitor the performance of the complete flow. We have added additional information in the data feed to qualify the end-to-end performance, and we have a real-time dashboard to see all the events. The target is to have an incident rate below 0.5%. I propose a small demonstration that we install on Renault. A rapid overview what we have in our plant. You see on the screen the central DFA supervision, where we have the complete view of what data we collect in different plants. The first information you see here is the number of value collected per second, and we have more than 10,000 value per second collected. We have here a second value about the number of subscription. We have here more than 1 million of point of measure collected, and we have here more than 700 OPC UI server implemented in all plant. And here you have for each plant the view of the collected data and the volume of collected data per second. And if we click in, we don't have time, but if we click, we can have the view of each plant, how many server, OPC UI server and equipment connected in each plant. The second screen I would like to show you is the number of equipment connected in all plants where we collect data. We can see we have made a ranking of connected factory, and each color corresponds at data model, specific data model. And we can see here in the most connected plant we have robot, motion device system, we have tightening controller, we have PLC, And we have another manual tightening motion device, function controller for welding point, an energy controller where we collect information about consumption of power of electricity in each installation. With all this information, we implement in different factory many data model we have decided. And the last dashboard is the number of data we collected in all plant. And we see we have 17 plant where we collect data. We have approximately 700 OPCUA server, and here we have approximately more than 3,000 equipment connected in this. And we have typology of data, file transfer and value, and the volume increase since 2 years with a very huge volume collected. At the end of 2019, we launched a program called Industry Data Management 4.0 to have a unique approach for the company on industrial data. At the data industry referential level, we contextualize the data to create digital avatar of vehicle process operation. At the data operation level, we develop all the use cases requested by factory. The ambition is to break down silo for manufacturing and the supply chain and improve performance. Google, with Google Cloud Platform, bring us their know-how on big data. Because we have contextualized the data, it's easy to develop use case with the unified data. An example on robotic area in body shop and from the data we have developed 3 use cases. The first concerns the monitoring of robot and roller table cycle time to identify workshop bottleneck. It is based on the data from the PLC. This use case is deployed in 10 factories and has generated significant saving in 6 factories. The second concerns the detection of sticky point on welding gun and rely on the collection of torques and position information from robot and vehicle information from the PLC. The third concerns the monitoring of parameters where the welding controller we seek to identify the drift of physical quantity to anticipate breakdown on welding gun. This made it possible to reduce the maintenance workforce. This is no longer any need to manually measure the resistance of the welding gun every week. To end this presentation, we would like to present our vision of the world of industrial data. Our dream is to implement OPCUA from machine to cloud. As the data is structured in the machine, it can be used by all IT systems from the dashboard, MES, ERP, or the cloud. This will ensure two-way communication, bidirectional communication, without modification and without development. We imagine an ideal world where the data will circulate without modification, only with configuration. For the long term, we believe that car manufacturers should work together to share a unified data model to avoid work at our machine supplier. From structured information, it is conceivable to have a rapid deployment of artificial intelligence and machine learning, and Google will help us to achieve it. In conclusion, we believe interoperability is a key part of the factory of the future. Group Renault have chosen OPCUA technology to achieve this. Thank you very much for your attention.